Okay, so there are two methods we use. One is the internodal injection and hot and cold. Internodal injection between two nodes, it's a hollow portion. You punch it and then you inject a sufficient amount of oil, close it with wax and roll it so that the oil gets coated inside. Basically, it will poison the starch. Starch is food for the insects. The second method is a hot and cold treatment, wherein you place it in a drum, heat it for 1 hour, cool it for 24 hours, so that the entire portion gets absorbed by the creosote oil. The third one is the dip diffusion method. This is we use a boric borax solution. How many of you play carom board? So most of you. So we use boric powder, right? So what purpose we use? For smoothness. There is another, you can use Pond's powder, but the problem is the wood veneer sheet gets deteriorated over the period of time. If you don't use it and keep your board aside, because the carom board is made up of wood veneer sheet. If you don't play, you keep it aside, after 6 months, small holes will come, the powder used to come. Even if you don't use boric powder, use Pond's or any other powder, talcum powder, same problem will come. Boric powder is another, chemical which will protect the wood, basically, from the insects. That's why we use the boric powder even for the protecting the wood veneer sheet of carom board. The same boric powder, we use it here for treating the bamboo. So you take 100 liters of water, 1%, 1 kg of boric and 1.5 kg of borax, make the solution, dip all the bamboos, whatever you want it to treat it, and then you take it out, dry it for 2 days and use it. So these are the three typical methods. Okay, what happens if you don't treat it? Suppose we treat, particularly this hot and cold treatment, why we treat, and what happens if you don't treat it? This is a treated and untreated column. Like wood, we have a graveyard test wherein there is an insect mound. They'll take a 2 feet stick, whether it is a wood or bamboo. 1 foot, they keep it, bury it below the ground. 1 foot, they'll keep it above. So over a period of time, they'll check, what happens, after 3 months, 4 months. Take teak and eucalyptus, do the same. Teak will deteriorate, eucalyptus will deteriorate because of the very nature of the wood of teak. So similarly, you can see the treated and untreated bamboo, after 6 months, you can see this is how it looks like if you don't treat it. And when it comes to the house, the typical house weight, 10 feet by 10 feet house, if you take, it weighs around 2.7 tons. Okay, so the loads that are coming in the foundation is also very less. So wherever the columns are coming, you go for a 1 foot by 1 foot, RCC column, and rest of the places you raise the, brick masonry or whatever. So you can see here, when you place the column, you have to anchor it. Otherwise, when heavy wind comes, when it lifts the roof, if there is no anchoring to the bamboo, to the, the footing, that will also lift. So we keep a 6-inch distance, we keep orthogonal direction, a steel rod, which will act as an anchor to the column. So once you place the columns, you connect all the columns with a wooden top plate, and then strip grid is placed, and then chicken mesh is tied to it and plastered, 1 coat, weight, and then final plastering done. This is how, it is similar to the ferrocement construction. The grid size is typically 6 inch by 6 inch. If you want to see closely the cross section, so this is the column. Typically, the column to column distance can be kept up to 6 feet. So beyond 6 feet, there is a lateral stability problem. So between to column spacing, one can go up to 6 feet, to 2 feet to 6 feet. Generally, they keep. Typically 4, 5, they keep. So between columns, the strip grid is attached to the steel rods, and then chicken mesh is tied to this and then plastered. One side, if you plaster, the other side it will come. Later, final finishing, you do it on both sides. Bottom, you keep a small steel rods at 6 inches. top wooden plate, you can nail it and then connect this strip grid using the binding wire, typical binding wire. And when it comes to the trusses, so most of the trusses, they make it on the ground and then lift it and place it, whether it is a small house or a big house or restaurant house or whatever it may be. Okay, so you take a piece of chalk and draw it and then place all the bamboos, and then so now people are using the gusset plate, either marine grade plywood or bamboo mat composite. They use it as a gusset plate, and then nut and bolt they are connecting and then placing the trusses and then using it. Okay, this is how the trusses are done. Yeah, I was mentioning that joinery is very, very important because to achieve the structural continuity, joinery is the most important mechanism, particularly in bamboo. So that the forces, wherever the forces, from the roof or from the truss to again the columns and columns to the wall to the, finally it has to be transferred to the, all the, the loads to be transferred to the foundation without any deflection or without any problem. So safely hurt. So earlier, people used the natural materials like tying, lashing using the bamboo strip or rope. These are the various, traditional methods. We all know, like workshop, we studied scarf joint, rebated joint. The most common joint is the fish mouth joint, where in northeast you cut the top of the bamboo in a fish mouth shape, and then place the bamboo and then connect it. So this is the most common way of connecting it. But the problem with the traditional joinery is when seasonal changes, okay, winter, summer, rainy season. So these joinery gets loosened up because it's a natural material. So slowly the joint gets affected, then the element gets affected. If once the element, finally it comes to the problem to the entire structure. So then using the steel structures, steel trusses, the gusset plate and nut and bolt is the most common way for the steel. So taking the inspiration from that, so people started working on it. Okay, people started working on it, and they've done a lot of studies on gusset plate and nut and bolt. Okay, and it has showed improved stiffness and strength when compared with the traditional methods. So there are different ways you can join it, any number of joints. Take the gusset plate and nut and bolt, and you can use either marine grade plywood or you can use the bamboo mat composite. There are different ways, because these are all straight bamboos, as I told you, Columbia and all. There are wherein you can use a small amount of steel, okay, as a joinery, inserting plates and connecting it either with a natural or and this is a fish mouth joint wherein you can connect it in a different way. Okay, this is mortise and tenon joint. We've even wood, particularly for furniture and all, dovetail and mortise and tenon are most common joinery we adopt for the furnitures. Yeah, here when you are working with bamboo, if any of the loading, if you are, directly that load lands on a hollow portion, okay, so then it gets crushed. Okay, so it is very important for you to make sure all the loading and the forces are transmitted properly. If any of the load is coming, it is better to land on a node portion. As I told you, node portion is a solid disc portion. If you can't avoid, if you are unable to avoid that, you can make it solid, the portion, only that particular portion, you can make it solid. How you have to do it, you can just make a hole and then send the mortar, and then you have to open it, that you should not close it. Any of the seasonal changes it will take. Okay. And when you are using it as a column, both ends, it should have a sufficient bearing area. What does that mean? You cannot place the column, you cannot place the hollow portion of the column at the bottom end, because it only, that wall thickness only will land on the foundation. So you have to make it solid or make it flat such that you can see, when you are holding the hand and placing it, that you cannot hold it properly when you are placing like this. So the bearing area is, you have to increase the bearing area. The same principle applies to all joints and connections. Very important. You have to create a more connecting area between any of the elements. This is very, very important. Many times what will happen, they'll just connect with the one nut and bolt and leave it. It is not the way. You just have to make sure this is connected properly. The area is connected properly. Can you change the wire? Is it possible? Okay, fine. So in some portions, like particularly foundations are more vulnerable. So if you go and observe any of the old structures, bamboo structures, if you are placing the columns, the bottom portion of the column gets affected. Maybe due to not treating properly, or it is directly exposed to the rain. Okay, if you don't treat it properly using the greased oil, the connection between the column to the ground, we don't want to happen. You can just elevate steel pipe, you can expose it to the outside, and then you can create. And also, particularly the foundations, number of columns, many people, we fascinate to provide, either due to the reason being the aesthetic, or sometimes to transfer the loads, heavy loads onto the ground. You can combine different columns in different ways. Okay, so you can bundle 2, you can bundle 3, you can bundle 4, but make sure it has got a proper integrity between these bundling. Very, very important. There are different roofing patterns also. Simple pattern, you can cut it into half and then you can put it one or the other, and then this is a very rough way of doing it. And there are people who has done, put the concrete over this, half split bamboo and then tested it. Okay, it is working well. The connection, they've used different materials like fiberglass sheet and all. These are some of the IS codes. I'm not putting a lot of stress on this. You can just Google it, you will get it. Or otherwise, these are the important codes, and some of the slides I'll send you. PDF I'll send to the, the organizers, and they will further it. There are method of tests for bamboo. If someone interested, they can test it, because most of the species are tested, and you can if you want, you can test it. Okay, some of the tests I have conducted a particular species that is called Bambusa bambusa, most abundantly available in Karnataka, and I'll tell you the difference between species to species. As I told, in one of the species, the density of fiber is different. That means the number of fibers in the bamboo for a particular species is different, the other one is different. So density changes. More number of fibers, more density, a different species. You can also recognize through that. So we have conducted some of the tests: compression, flexure, shear, free vibration, full scale. This is a compression test we have conducted to tell normal, if you want to calculate in future. A typical single bamboo pole can able to take half a ton load without deflection. Say 7 feet bamboo of 4-inch dia, with a minimum of 14 mm wall thickness, can able to take half a ton of load, 300 to 500 kgs of load, without deflection. So that's the potential of the bamboo. So we have tested by keeping only hollow, because there are 3 cases you can get. One is a completely hollow bamboo, node in between, and node on either side. I've told both sides you have to increase the bearing area. Here you can see, the more both sides, if you create the more bearing area, your strength is more, your modulus of elasticity is also more. So when you test it, while testing, if you measure the deformation also, strain is the deformation, stress versus strain, you can plot the modulus of elasticity. So you can see the difference. So this experiment tells you that you have to create a proper bearing area on either end. You can see here the strength 33, 30, 44. The nodes will also give some kind of impact on the strength. So again, when the height reduces, strength is a different. That's what we call it as slenderness ratio. Okay. Next, very, very important property is shear. Shear is the most important property, particularly when you are working with bamboo, because you are connecting different elements. When you connect with nut and bolt, so any of the movement, the nut and bolt, finally the effect goes to joint, the nut and bolt will shear off. That means it will move. So shear is very, very important parameter. That is why wall thickness plays very important role. So if you don't have a proper wall thickness, what will happen? It will cut off. So we designed a mechanism wherein we made a slit, we put a small steel plate and then applied the load. We understood what is the shear strength. It ranges between 4 to 11. Again, it depends on the wall thickness of the bamboo. So here it says, like, if there is a more shear, particularly windy areas, if you are placing the roof using the trusses, so a lot of forces will get into the joinery. So you make sure you have a proper wall thickness to the bamboo, and also nut and bolt size also makes. Nut and bolt you have to choose properly, gusset plate you have to choose properly, and at the same time the wall thickness of the bamboo you have to maintain properly. Anyway, we did a free vibration test using accelerometer, just tapping it and then getting the value. I'm not stressing upon much on this. Flexure tests also we have done. Full scale tests we conduct, like single bamboo pole and then double bamboo pole. So we got the strengths like this. As I told you, in a rough way, 500 kgs it could be able to easily take if a proper wall thickness is there. You can see the split, you can see at different places if it is a single bamboo pole. But even though you need not worry, but still what we did, after testing, we still placed that bamboo in one of the construction to make sure how it behaves over a period of time. This is very, very important. And with different heights, we checked it. I'm not boring you with these equations and graphs. Okay, next is tensile strength. Okay, how do you measure the tensile strength? Usually you cannot hold the entire bamboo and pull it out. So strip, you can test it. This is where people will say, like, equivalent to steel. This is the property people will talk about, like, the bamboo is equivalent to steel. It shows the same behavior as steel. When we pull together, see, basically the bundle of fibers. Okay, so when you pull bundle of fibers, it won't come easily. Okay, that is the strength of the bamboo. Okay, so anyway, inside the glue material, what we call it as lignin is there. Okay, so you have to make sure the number of fibers, density, nodes, all these things are very, very important when you are using it. Next is, this is just a National Building Code, directly I've pasted it. These are the species, you can see. These are the values. Someone wanted to know the values and, work it out. And also grading, structural bamboo grading they have given. So if you wanted to categorize, okay, for a bigger projects, okay, they have given based on the modulus of elasticity and other things, you can see. And there are a traditional way of connecting, I told you. So pins, wooden pins and steel nut and steel bolts and all. So both, when we tested, like you can see that only 56% of the load it is taking when compared to the steel nut and bolt, wooden pegs. Okay. So now I am coming to the elements. So the wall elements I showed you, like bamboo strip grid and chicken mesh and then plastered. These are the wall elements. They're trying it in particularly Costa Rica and other places. Okay, they are using this bamboo because bamboo is more abundant there in such places. They've used it for their colonies, but many of these colonies are affected due to some of the earthquakes. Okay, so the universities have conducted studies on different wall types. Changing the grid pattern. Changing this thing. I'll show you in a later stage. So the first thing is trusses. Truss is the most the common element, roof element. We use it in bamboo structures. Okay, whether it is whatever truss it is, king post, queen post, or whatever type, scissor type. Or so we have tested various type of trusses with different spans. 3 meters, 4 meters, 5.5 meters. Typically, the design load is this much, around 2 tons, 2.3 tons. But it is taking 2.5 times the design load with a minimal deflection. The trusses will take much higher load compared to the design load. As I told you, joinery is a very important parameter. Here, what I wanted to stress is when you connect, when there is a problem at a particular joint, there is a problem of shear. Okay, if you connect the nut and bolt away from the node, okay, it will take less load. So we tested it, like, so you have to make sure there is a node. So if you connect it, this nut and bolt will not cross that node. So that gives you more strength. You can see here, bearing towards node is 940. When it comes to the away from the node is 820. Something like that. Okay. Even the deflection is also more. Deformation is also. And also we tried different nut and bolts, 8 mm, 6 mm, 10 mm. What happens? And also different wall thickness. Like, gusset plate, 6 mm, 8 mm board, 10 mm board. Very, very important. Which one, performs better. Okay, now I'll talk about the performance of the whole house. Okay, so I'm talking in terms of the earthquake resistant. So before that, I just would like to mention some of the traditional houses in northeastern part, because northeastern part is a more seismically prone area, northeastern and Kashmir area and such places. There is a type of housing, what we call Ikra type of housing, more prevalent in particularly Sikkim and other areas, wherein up to 1 meter height, they go for a stone masonry. Above that, they rise wooden frame they place and then strip grid and chicken mesh and all. So during 6 and 11 earthquakes, Sikkim earthquakes, these houses are not affected much. There are little bit of falling of debris, but there is no harm to the human. Okay, but the problem is it is not suitable for higher stories because the very basic nature of this thing. So these are some of the barrack variants. I told you only 6-inch by 6-inch grid. One can go for a different kind of variants. The pattern of strips, you can keep it. These are some of the houses in Colombia and other places. The same bamboo houses with a strip grid and plastered houses. So this is the Daji Diwari type of construction. Very famous in particularly Jammu, Kashmir and those places. Darji, what he'll do, he'll take a piece of cloth, cut it and stitch it and finally make a proper cloth. So here also, there is a frame. In between frame, they place it. Different materials that are available in that area. They make a wooden frame, bracings, and then fill them that particular spaces with the whatever material that is available. So these houses, particularly the confinement, whatever you have provided using the timber frame, it is very much seismically prone, and most of these houses are never damaged, not much damaged during the earthquakes. There is another type of construction, what we call tack type of construction. In Daji Diwari, you place it in a different. Here only you run the wooden members horizontally. So between wooden members, you just place the different materials, whether it is a block or whatever, tile or whatever. So this also improved the lateral load resistance, particularly in these houses. Why I'm telling? So one of the student there in Srinagar, he has tried because wooden is getting scarce. Why not? Because bamboo is available. He has tried using the bamboo. You can see these are the wooden frames of different Daji Diwari type of frames. Okay, the above is the same type of frames with a bamboo as a replacing material in the same place. You can see So when they tested, it is giving 1.5 to 3 times more resistance, particularly in the bamboo, obviously. So this particular second type is giving a better resistance to this. I just wanted to mention because the way the bamboo has been used at different places. Yeah, Simon Welch work, if you Google it, you'll get a lot of good work, okay, by Simon Welch. But because he's having a particular striped material, that species name is Gadu angufestula. It is just like, a better steel. So it has got 2 rings. In single bamboo node portion, only 1 ring is there. It has got 1 over the above, 2 rings is there. Very striped material, and it is capable of having, without splitting nails, you can do it because the fiber density is much higher. That's how they could able to do very good structures. We have definitely, we also, as I told you, we have a more of clump forming bamboo, sympodial bamboo. Anyway, these houses, as I told, during different earthquakes, San Salvador and El Salvador earthquakes, these are also got damaged. Then universities have come into, sorry, the slide was earlier shown. So the university have come forward and tried different kind of walling patterns, and then implemented later in some of the colonies in those countries. Later, during Costa Rica earthquake, these houses not damaged. So there is a lot of, the role of universities and colleges, academia and industry role is very important, particularly to improve a particular material. This is my work I've done at Colorado State University. When you go to a foreign university, you are bound to do everything. Luckily, I've constructed one small house on my own, including plastering and everything. So there I did 2 walls, just to know the seismic behavior of this particular wall. So I did the plastering and all. And this is a wall without window. This is a wall with window. We did a cyclic test. Cyclic means you just keep applying the load and take it out. Apply load, take it out. So cyclic loading experiments we have done. So here, there is a middle bamboo, it got crushed. Because in US, they have brought the bamboo for a different purpose, my professor. So you know what purpose he has brought? There is a lot of mountain biking they do, okay. So at mountains, they've used bamboo as a barriers, okay. So for barrier testing, I was involved in that project also. So we made the barriers and then we tested against, protecting the people who are doing the biking in the mountains. So that bamboo is not very great, like wall thickness and all. We have used the worst bamboo, whichever is possible. Whenever you are doing research, you have to do that, worst case. So crushing of middle bamboo is there, and then we did some modeling and so on, and applied different earthquakes on that particular values, and then it is very safe, particularly in terms of seismic performance. Only we tested walls and then numerically modeled the house, okay. So later I wanted to test the full house, okay. So full house testing, I'll show you. We did the full house testing. So to test the full house, there are 2 ways you can test it, any house. Okay, one is a shock table, another one is a shake table. So which I was involved in one of the project, National Science Foundation project in US. So here, the table will move in 3-dimensional. Okay, so you build a full house. So here, it will move in unidirectional. A simple pendulum physics, just pendulum will hit. So if you increase the angle of the pendulum, the more impact it creates on the table. The vibrations will occur. We'll see how the wall has got damaged. So this is the one I was involved in, this 7-story wood building. I was there for 2 months. We built in 1 month this full apartment structure, 40 feet by 60 feet. So every day take the nail guns. My professor used to bring nail guns. So we used to go place it. We only have to do all the nailing and other things. So we built it in 2 months, and then we did the testing. So this is so that time I was involved in training almost 100 Japanese students. Wherein, see, once the test got over, we have to inform them, like you have to go to first floor, record the damage and other things. Anyway, so similarly, we have a table, okay, shake table in CPRI at CPRI Bangalore. So we also have tested the full scale building on shake table. So that is, but this is very small, 3 meter by 4 meter. We applied different kinds of repeated zone 5 earthquake simulation, Kobe earthquake data you can give and test it. But the structure did not exhibit any kind of crack. So we thought of doing number of tests. But to test again, it is very expensive. 10 lakhs they charge. To establish, they'll take 2 crores. Very expensive. Then thought we understood there is a different way of testing the building. Okay, so in Nirma University campus, Ahmedabad and all, they've IIT Roorkee, they've tested the reinforced brick masonry buildings. Okay, so after Bhuj earthquake, one of my Professor K.S. Jagdish from IISc, Indian Institute of Sciences, involved in improving the building's behavior. So basically reinforcement, giving the reinforcement to the building. So even we tried later bamboo as a reinforcement strip for these masonry buildings. So then we took the same concept, table, I made it, I took a project. Only thing is, that frequency. Table frequency, when we made, it is 131 Hz. So initially we tested what is the natural frequency of the house. Natural frequency of the house is 13 Hz. So your table frequency must be much, much higher than the house frequency. 13, this is we designed to 131 Hz. Then one of the training program, when we are training the Northeast people, so we build this house. This is the pendulum, changing the angle, hitting the, you can see. This is the impact we created. When you change the angle, the impact energy will change. Only very minute cracks occurred. You can see. So then we built a different model, second model.
45 degree.
Okay, ready? Come and hit the tape. It creates vibrations. So we observed the crack propagation of this bamboo reinforced house. You can see, observe, the crack is getting widened. Okay, where the crack will start. So we can understand the failure mechanism of the building when it comes to any of the forces. So similarly, the other wall. This is also the other wall, you can see. So this is the last trial.
Trial 50, angle 55, start.
Got twisted. The bottom to the table, to the house, got sheared off. We stopped. So this is the final, it is completely twisted, but the building was not failed, in the sense it is still intact, nothing happened to the building. So that is much, much higher, like, after, you can say 10 earthquake impact we created. So this is the final house, the crack pattern you could see. So then, after testing it, so BMTPC, that Building Material Technology Promotion Council, New Delhi, they gave a project that traditional Assam houses they are making. They are like, this mat, over the mat, they are just plastering it and they are living in it. What is the condition of, can you test it? So then we took a project, this is the condition. So, because the plaster was not proper, usually when you do the plastering, particularly for earthquake, seismically prone areas, this is how it happens. Then after testing, we gave measures and BMTPC implemented later in such houses in northeastern part of India. Okay, next one, here afterwards, I'll give you 2-3 case studies and then we'll have an interactive session. There is a bamboo tensegrity structure, very famous, one can try it. We just tried with our students. It was done by Buckminster Fuller these are the simple videos you can see. I asked her, she's in final year. She wanted to do a tensegrity structure. So then I asked her with the eye sticks and with the thread, you prove it. Then I told her to make a, you can see, it can able to hold a particular weight, particular amount of it. So a lot of applications, particularly tensegrity structures, very interesting structures. So then actually we wanted to make a pergola. So I asked her to make a computer table initially. With that we are extrapolating. So we took a plan, virtual model we have taken, then real model. We did the deflection studies and things like that. Then two elements we've taken. One is jute rope and another one GHA. Okay, with the combination of bamboo. So this is how the prototype we made. One is with the chains, and we tested, how it looks like. So before that, we modeled properly and then did that. You can see the picture.